Pre-Calc, today we are going to talk about probability and odds. So probability is, and if we look at the definition, if an event can succeed in S ways and fail in F ways, then the probability of success and the probability of failures are, this is successes over successes plus failures. Well, successes plus failures is really the same as the total. So really can think of this as, when you add them together, it's equal to the total number of items you're talking about. You can also talk about the probability of failing. What's the probability of failing? Well, it's the failures over the total. Okay? So just to kind of look at a simple example, it says, what is the probability that a marble selected at random is yellow? So let's say this is, it's a win if you get yellow. So how many ways can it come up yellow out of how many total? And remember, the total is all the yellows plus, that's a win, plus the ones that are not yellow. And if we want to think of that as a fail, we can think of that as a fail. So this is 5. The total is successes plus the failures. So this is 5 out of 14. Okay. All right. I'll just, this is yellow out of total. Okay. Look at the next one. What is the probability that a marble selected at random is not white? Okay, so this time we don't want it to be white. If we want to think of it that as a failure, we can. But if we just want to think of it as how many are not white out of total, so the number that are not white in this case, well, it's the yellows plus the blues over the total. So if we want to think of that as fails plus successes, we can. That's 11 out of 14. So, just probability you've known from the past. It's just how many ways does it come up the way that they're asking for. So how many ways does it come up not white? 11. How many ways does it come up anything? So how many total marbles are there? So how many marbles are not white out of how many total? All right, so that's kind of thinking of it in very simple terms. But remember, in the last unit we did, the last lesson, we talked about combinations. And so now we're going to use probability with combinations. So here it says a circuit board with 20 computer chips containing 5 chips that are defective. If 3 chips are selected at random, what is the probability all 3 are defective? So now we're not just taking one marble or one chip, we're taking a group. And anytime we take a group, we usually have to use combinations. So I want to think of how many ways it can come up 3 defective. 3 defective chips out of how many we can get 3 of any chip. All right. So how many are defective? Well, out of 5 total defective, how many ways can we choose 3? How many total ways can we pick 3 of any chip? Well, there are 20 total chips. How many ways can we pick 3? So, we're still looking at if it's a win to get, or a fail, whatever, to get 3 defective chips, how many ways can it come up 3 defective? Out of how many ways total ways can we get 3 of anything? All right, so again, on my calculator, I can punch 5C3, and it'll come up 10. So remember, we do that, we hit 5, then we go to probability, hit the probability key, and in the probability key, we'll have a C, I think it says NR, and then we hit 3, and then we hit equals, okay? If I do the same with 20C3, I should get 1130, okay? And chance probability. I could reduce it to 1 out of 1130. I could also change it to a decimal by going 10 divided by 1130. I'm just going to leave it at that. Okay. So now this is at least 2 are defective. So at least 2 are defective means 2 are defective, or it can be, so we'll add up all the possibilities of 3 are defective out of the total. Now we have to remember we're still taking 3 chips. So if 2 are defective, it has to be 1 that is not defective. Make that a little bit better. So 2 defective and 1 not defective. All right. So how do we write that? So again, this is 2 defective, 1 not, plus 3 defective. We already know the 3 defective because we just did that above, right? Out of 5 total, how many ways can we pick 3 that are defective? Out of 20 total, how many ways can we pick 3? The total is going to be the same down here too, 20 and 3. But this is the part that's a little different. 2 defective and 1 not. Well, if we're just getting 2 chips that are defective, out of how many defective chips are there? There are 5. Out of 5 defective chips, how many ways can we pick 2? But that's together with 1 that's not defective. So out of 15 defective, how many ways can we pick 1? All right. So 2 defective and 1 not is how we're going to write out that one. And of course the total is out of 20 and 3. All right, so I guess I'll write it down here. If I do the 5C2, I would get 10. If I do 15C1, I get 15. And again, 20C3 is the same as before. It is 1140. You know what? I'm sorry. I just have to correct this up here. This was not 1130. This is 1140. Let me just erase that. That should have been 10 out of 1140. Okay. Because when you put 20C3 in your calculator, you get 1140, not 1130. I was thinking of something else there. Here, 5C3 is 10. 20C3, again, 1140. So if we add 150 plus 10, we get 160. Over the total. So remember, when we add fractions, of course, we only add the top. We do not add the denominators. And the denominators have to be the same in order to add them. So the probability that if you pick 3 chips, that it's going to have at least 2 defective, that's 2 defective or 3 defective, is 160 out of 1140. Now again, I could reduce that fraction. You can just leave it like that. If I wanted to change it to a decimal, I would go 160 divided by 1140, and I would get 0.140, or that's about 14.0%. 14% if I wanted to change it to a percent. We'll just leave it as a fraction. All right, now we're going to talk about odds. So the difference between probability and odds is probability is how many ways it comes up out of how many total. Odds are how many ways it comes up out of how many ways it doesn't come up that way. Well, another way to think of that is not just how many ways it comes up out of total, you can think of it as, I'm sorry, how many ways it comes up that way out of, how many ways it doesn't come up, we can think of it this way. We can say successes over the total minus the successes, for example. All right, so I'll show you what I mean here when we talk about odds for number 3. So we're going to start off by probability again. What is the probability of choosing a blue card? So of course this is blue out of the total, right? And the total is successes plus failure. So how many blue out of how many are blue plus not blue? So this turns out to be 12 out of 22. Of course I could reduce that. I'll just leave it as is. This is the what we're talking about with odds. It's how many are blue compared to not blue. Well, we can probably pretty easily see in this case that 12 are blue and 10 are not blue. So we can just write it as 12 to 10. But another way to think of it is, again, how many are blue compared to the total minus how many are blue. Writing it out this way is just going to help us a little bit when we throw in some combinations. So we can say 12 over 10. I like to write odds with a colon. So it's a 12 to 10 ratio. So the odds that you're going to get a blue are 12 to 10, or you can reduce that to 6 to 5. The odds of a green card, so how many are green compared to not green? Well, there are 10 that are green. If we take the total minus the not green, that's 10 to 12. Or the odds are 10 to 12. So again, here we're talking about blue successes. We think of that as a success. To the total minus a success. So the total minus a success, total is 22. We minus the successes, we get 10. So same here, not green, total minus the ones that are not green. I'm sorry, total minus the ones that are green are the ones that are not green. Okay, so it's like, okay, why is she making it more complicated when all you have to do is green compared to blue? Well, it's just going to help us out now when we throw in these combinations, and it's a little harder to see which ones are that way or not that way. Okay, so we're picking out groups again, so that means combinations. It says 4 male and 2 female, so 4 male and 2 female students have been selected as equal qualifiers for 2 college scholarships. The awarded recipients are chosen at random. So we're taking a group of 2 again. So a group of 2, so that means a combination. What is the probability that both are girls? So how many ways can you come up 2 girls out of 2 of any? So we're going to start with the probability. So how many ways out of 2 total female students, how many ways can we pick 2 girls? The total girls are 2 and we're picking 2. Out of any, because this is the total, out of 6 total, how many ways can we pick 2? So if I do 2C2 in my calculator, I get 1. If I do 6C2 in my calculator, I get 1 out of 15. So how many ways can I pick 2 girls? That makes sense. If there's only 2 girls to pick from, there's only one group of 2 girls. So that logically makes sense, but it comes up that way when you punch it in your calculator too. How many ways can you pick 2 of any of these? If there's 6 total to choose from, how many groups of 2 can equal 15? So what's the probability that the 2 girls, or the 2 people are going to be both girls, 1 out of 15? What are the odds that they're both girls? Okay, so this is 2 girls. So this is where it's a little easier to think of how many groups of not girls are there. It's easier to go total of any two minus the ways we can get two girls. All right? So again, if we're thinking of it as successes to failures, the successes are two girls. The failures are not two girls. So how many ways can it come up not two girls? Well, all the other ways minus all the ways it can come up two girls. So we already know how many ways can we pick two girls. Out of two total girls, how many ways can we pick two? Total of any two is 2. And then we're going to minus that one there. So we know this is a 1. This is 15 minus 1. But again, I like to write odds as a ratio. So here is a 1 to 14. The odds are 1 to 14 that they're both going to be girls. So two girls, there's one way it came up that way. How many ways did it not come up two girls? 14. All right. What are the odds that one will be male and one will be female? So now we're going, how many ways can it come up? One male and one female. Oh, compared to all the other ways, because this is odds, right? So how many ways can it come up this way compared to all the others? So we're going to say total of any two again minus all the ways we can come up with one male and one female. All right, so how many ways can we come up with a male and a female? Well, this is all the ways can come up a male is out of 4 males, how many ways we can pick up one, and out of 2 females, how many ways can we get one female? So it's all the ways we can pick one male and one female. Okay? Now the total of any two is going to be just like we did before. It's out of 6 total, how many ways can we pick 2 minus how many ways can we pick one male and one female? We're subtracting those two. So if I calculate this, it's going to be 4. If I do 2C1, it's going to be 2. We already know 6, 3, 2 is going to be 15. We calculated that above. And this, again, is going to be 4 times 2. So this is going to be 8 over 15 minus 8, which is 8 to 7. 4. Like this, 8 to 7. All right. So all the ways, there's 4 ways it can come up. You can pick a boy, right? Which is, if you look up there, how many ways, if there's 4 to pick from, how many ways can you pick a boy? Well, 4 different ways. How many ways can you pick one girl? Well, you have 2 choices. So 4 times 2 is 8. And then in the denominator again, you do the total minus how many ways it comes up, one male and one female. So 15 minus 8 gives us 7. Okay? So, probability and odds can be very basic. So if you think about how we started here, how many yellow out of how many total, or in the case of odds, how many blue compared to how many not blue. But then it gets a lot more complicated, of course, when we are taking groups. So anytime we're grabbing a group, we have to think of combinations.